Hey guys, do let me know if I'm audible as well as visible. Sure. Okay, I'm really sorry guys, there was some technical issues and somehow we got late with that. Uh, Apologies for the delay. I hope I'm pretty much audible and visible to one and all present in the chat today. I apologize for a slight delay here. So we were having some technical challenges and I think it's pretty much sorted now. Cool. We are almost 10 minutes off our schedule. I'm really apologize for that. But again, without doing any further delay, let's quickly start. I would welcome each and everyone whosoever part of our chat to put up your questions so we can take it up live. So if you have any queries regarding from the previous lecture or anything which you feel that you might need my support in, we can always talk there. Cool, guys. Without wasting time, let's quickly start. So, with a quick round of introduction, as you know, my name is Arpit Jain and I'm a senior data scientist myself. I have almost 9 years of industry experience. I'm a motivational speaker as well. Along with that, I take career mentorship sessions. So, I talk to students regarding their career, jobs. So, do let me know if I can be of any help regarding your job or anything regarding your career which you want to talk about. So, we can talk about those things as well. As part of the subjects, we'll be talking towards Python, SQL, data science, as our stream says. So Python is more towards. We started 3 months back, so we did some good things there. SQL about a month back. Data science will start. We also started 2 weeks back, and that's where we are in at. So data science, we have clubbed it with Python. So we are doing multiple conceptual understanding of data science with Python, right? So that's what we are at. And we started with visualization. So that's a very primitive way of analyzing the data, right? For the data analysis part, visualization is the key, and that's what we are doing. And we have finished Seaborn. So we are doing visualization through Seaborn. Today I'll be concluding it. I'll just give you a kind of a framework, like what graph to choose when, what are different options are available, and maybe a kind of a guide for you, right? So that can always help. So along with that, guys, you have the code right in front of your screen, which is Python 10. So if you're going to use this code Python 10, you're going to get a 10% off. Not here. So you're going to get a free sample Relevel test paper. So Relevel again is one of the testing platform. You know that, right? So it's here. If you use this code Python 10, you're going to get a free Relevel bonus sample test paper. So now coming back to this, what is Relevel? So time for a quick promotion. Please bear with me for that. So many a times the candidates do miss out on the great opportunities due to multiple reasons. And it could be like they don't have a better degree or not having the right networking, right? And also the resumes through which they're applying so does not really stand out because there are at least 100 other applicants. So some issue might be in the resume or something which is really external, which is beyond your control. Also, the candidates are applying to a number of jobs, but still you're not getting even a single call for your interview. So very practical problems, we all face that. To cater these problems only, the Relevel has been introduced, and it's India's first test hiring platform by Unacademy, which is actually helping you to get your dream job. And here you're purely dependent on your skills and talent, and nothing on sort of a degree or your networking. So it's purely on your skills. So how it happens here, it's more of a testing platform where you'll be asked to go through an assessment, like a test, right? And the only expectation from you is to get the best score out of this test, okay? And that internally is dependent on your knowledge, right? Purely on your skills. No sort of degree importance or networking. So it's purely on your skills. If you're knowledgeable enough and you're able to get the good score, that's the only requirement here. And then followed by that, the companies will start reaching out to you for your jobs. There are certain other benefits also involved as part of your Relevel testing platform. So I'll brief you on some of them. So at least there are 50 plus companies, including the top startups and the unicorns, which are hiring directly from the Relevel platform, including ENY, Upgrad, Cred, Razorpay, Urban Company, and many more. Right, and also at least there are 1,000 plus open job position across 3 different portfolios: business, front end, and the back end development. Right, and also this is completely online, so you can take this from the comfort of your home. and again, the good thing is it's completely free. So you're not going to pay even a single penny for your test. So you can attempt it for free. Right, the only expectation is you have to finish the entire test in a single day. There are multiple rounds involved, so you have to finish this entirely in a single day. The scores will be revealed in a week's time. So that's the only thing. So yeah, the qualifying score right now is 70%. So overall is 1000. So you have to score at least 700 out of 1000 to make your Relevel profile. But again, if you're not scoring well, you can reattempt it, but that can happen only after 30 days, right? So with this, you are in a unique position, guys, to invite interest from companies instead of you hunting for your own opportunities, right? So once you're given the task, just sit back and relax. The companies will start reaching out to you once you have the right score with you, right? Registration is also quite easy. You know this. You have the link in the description. So once you go there, the first thing they will ask you to choose a test of your choice. Business, front end and the back end development, multiple roles. You can see that, right? So once you have selected the test of your choice, the next thing they will ask you to choose the date of your choice, right? Slots are limited because it's a beta platform. So I would request you to really book it fast. The last thing would be to fill up your demographics like full name, email ID, birth year, state, along with your gender. So you have a referral code, so you can put up the promo code, which is Python 10. If you're going to use that, you can unlock your bonus sample test paper similar to the actual test. Once you have created your account with these details, you can see the logged in screen with your name, and on the practice tab on the left hand side, you can see the bonus sample test paper for you. This test paper is the replica of what you're expected to have in your real assessment, right? So it's a very good guide to have a fair understanding of the complexity of the problems. So please, guys, do register it. So it's anyway free of cost. So you can try it for once. Later, if you feel that you're not getting benefited, you can decide it later. But at least you can try it for once, right? Also, the Telegram channel, guys, link in the description. Please do join this. One place stop for you for all your upcoming schedules and classes. At last, please do like the video if you feel that you're getting benefited, right? So that's the least we can expect from you. So with this, we are into a content slide for Seaborn, right? So we have already covered almost all the graphs from Seaborn available, right? So anybody has any questions from that, do let me know, right? Or else I'll jump to the Seaborn part, right? So I can just brief out on that. But again, I'm okay to take any questions if anybody is having, right? So right now, we have been discussing a lot of things, a lot of graphs on Seaborn. So we have already seen that, right? So let me jump to Seaborn quickly, just a minute. So I have my screen is visible to you all, right? So we are into Seaborn. So we have finished till my heat plot. So that's my heat map says, right? So again, hello Sandeep, thank you for joining in. So I'll just give you a quick, what's say a cheat sheet kind of a thing. Okay, so how exactly it works. So always remember, guys, how the graph works. So broadly, graph may you have two things, right? So the first is the background, like how the layout of my graph looks like, right? So I mean how you frame up your graph and how you want your graph to look like, right? So that's like a look and feel of your graph. So that's the first, like aesthetics of your graph, right? We call it the aesthetics of my graph. So that's one thing. Second is on those aesthetics, what data you want to plot, right? So yes, Sandeep. So I'll be anyway concluding everything today. So I'll be giving you at the end a quick recap. But again, I'm giving you what all different options are available with me. So we can just frame up those graphs again. So technically, so there are broadly two types of thing which you're doing in visualization, picking up the graphs, right? The first is you're framing up your graph, like you're setting up the style and the background look and feel of your graph. So that's the aesthetics part. The second is the data, right? So what data you want to plot on top of your graph. So that's the second part, right? So on the aesthetics front, we saw three options. The first is you can set the context, right? So you can set the style basically. So there are two things, the style and context. Style is basically like you're framing out your background, like dark colored background, white color background with checks, with no checks, right? So all of those things. So it's basically two words, and it comes with the function called as set style, right? So you're setting the style of your background. So in that you have grid, no grid, white, dark, and all that. You remembered, right? And then also along with that, you can change the colors of that grid. So maybe I don't want a white colored default grid, I want a red colored grid, right? So, and then a lot of multiple options, so you can just play around, and it comes with the axis style functionalities, right? So broadly, it's a function called as set style to set your theme to the background. The second is the set context. So in this set context, you are scaling your data. So again, in the graph, you're scaling your information, the x and the y axis. You're scaling your x and the y axis. I mean, you're changing the ranges of your axis just to make sure that whatever way you want to say this. So again, you have multiple options like notebook, poster, I think talk, something like that. So you have 2-3 options also there, depending on the scale on the graph which you want to see. You can change the context of your graph. So again, these two functions are basically coming towards my aesthetics part of my graph, right? The last is my color. So you can give a color theme, right? So you have now on the entire data, you can plot what on the data part, you can what color you want to choose. So on the color front, we have again multiple options. We have color palettes. We have seen that sequential colors, my random colors, my divergent colors. We saw that. So these three are my aesthetics front, right? So set style, set context, and my palettes, color palettes. So these three are the major parts of my aesthetics, right? So to my first agenda of my graph, correct? Now the second is coming towards my data. So whenever we are plotting your data, we have some agenda, we have some expectation from the graph, right? So this is what we want from the graph. This is what we want to see, right? I hope that is pretty much, okay with everyone else. So in here, when you talk about the overall table, overall data frame, whatever we have, right? So we have a different number of columns, different types of columns. So technically, there are two types of columns, either a number or a non-number, right? So agar data में numbers है like 1 2 3 4 or floats or integers or decimals, whatever, right? So some kind of number, numeric or non-numeric, right? So technically हम समझ सकते हैं in the data we can have numeric or non-numeric kind of a data, right? So broadly ऐसे समझते हैं. So now here the data graphs are again broadly divided into two parts, the univariate graphs and the bivariate graphs, right? So univariate means I'm trying to analyze a single graph, a single variable, single column, और bivariate में I am trying to analyze two columns added together, correct? So technically graph में plot करने के लिए कुछ ना कुछ number चाहिए होगा आपको. So how will you plot? I mean, you cannot just plot a non-numeric data by default, right? So you have to have some data, some numbers to plot on your graph, right? So univariate में you are actually doing an analysis on a single variable, right? So that single variable, it's a non-numeric data, does not really make sense. You cannot just plot a graph on a non-numeric data, single alone, right? There's no plot at all. So by default, if you're doing a univariate analysis, it has to be a numeric column. I mean, that's pretty much understandable, right? So univariate analysis में मतलब you're doing a single variable analysis, and single variable अगर non-numeric हो गया तो plot क्या करोगे आप, right? So उसको तो numeric होना mandatory है, correct? So again, in the univariate में you have the major plot which you are doing is, which you are trying to understand is the distribution of my data, like how my data is distributed over all my entire space, right? So that's where my distribution plot comes into picture, my dist plot. Correct. So that's this plot for you. So where you saw that histogram kind of a thing coming up, right? So a rectangular bars and a run chart. So इससे हमें क्या पता चलता है? We are trying to understand the distribution of my column. So like whether the data is normally distributed. Normally distributed क्या होता है? A bell curve or a reverse U curve, right? So single like a sine wave, a single crest or a crest of my sine wave, right? So it's like a simple half sine wave. So that's what we call it as my normal curve, right? But again, if there are multiple peaks, multiple troughs, or also if there is the data is like a tailed one, like right side में बहुत सारी information है, and then left side में बहुत सारी information है, तो skewed data है. So we have like in the circuit the data is not normally distributed, right? So that's what we understand from distribution plot. So इसका inference क्या है? What do you infer out of distribution plot? Is like how my data is distributed, right? So how my data distribution is normally distributed hai ya nahi hai types. So this is my inference. That's about my univariate analysis, right? Now on the bivariate front, so now on the second broad class is bivariate analysis. So in bivariate analysis, you are analyzing the graph across two different variables. So there is an x-axis and there is a y-axis, right? So now here, x-axis and y-axis, they can either be both the numbers or they can be one non-numeric and other one as numeric, right? So bivariate में again further two classifications. I have numeric to numeric graphs or numeric to non-numeric graphs or a categorical graph, like a string kind of a data, right? So first numeric to numeric में क्या क्या हमने देखा था मेजरली जॉइंट प्लॉट. आपको याद होगा जॉइंट प्लॉट क्या करता है, इसका अगेन बेनिफिट है. सो जॉइंट प्लॉट में हमने देखा था कि इट गिव्स बोथ द बाइवेरिएट एज वेल एज द यूनिवेरिएट ग्राफ. सो सेंटर में वी हैव एन ऑप्शन टू यूज लाइक द बाय डिफॉल्ट इज स्कैटर. सो दोनों नंबर के बीच में स्कैटर प्लॉट बन जाता है. स्कैटर प्लॉट क्या होता है, इंडिविजुअल ऑब्जर्वेशंस को 2D प्लेन पे वो प्लॉट करता है, राइट. सो सिंपल एक्स एंड वाई का कोऑर्डिनेट्स निकाल करके कोऑर्डिनेट्स के हिसाब से एक्स एंड वाई पे प्लॉट करता है. दैट इज माय स्कैटर प्लॉट, राइट. But on the top and the right, you're also seeing the univariate graphs of my individual axes also. That's the benefit of my joint plot, right? इसमें दो further divisions हैं. आपने देखा था hex bin and आपने KD plot भी देखा था. तो hex bin basically क्या है? Here in the scatter plot, you're seeing the observation, like the correlation of my x and y, how strongly or how weakly, and what is my strength, how my this data is varying, how x is varying with respect to y. So this is what my scatter plot is giving, right? But if you want to see the density of my information, like where in the particular region more number of observations are present, right? So the density of my data. So I want to see which is the stronger locality of my information, where the data is more concentrated. So in that case, you can, instead of using a default scatter, you can use a hex bin. So instead of a scatter plot, you can just plot a hexagons on top of that. So darker the shade, more concentrated the density is, right? Again, also KD options you can plot in terms of a line chart. So that's my joint plot. So if you don't want both the univariate or bivariate, you can have a by default only a separate line chart or a scatter plot. So again, on that we have a function called as rel plot, relation plot. We have two different kinds available here, scatter plot or the line chart. So both are possible. So we are only doing the bivariate analysis on two variables. Okay. So that's about your numeric to numeric graph. So we discuss about these things. Now comes my numeric to categorical graphs, right? So where one column is a category and other column is a number, right? So that's what we also understood. So in this case, we again have multiple options. We read about swarm plot, we read about this strip plot, and we also talked about in terms when we moved ahead, we talked about box plot, violin plot, right? So point plot. So these all are some interesting bar plot also. So these are very interesting graph where we are plotting something on categorical to numeric, right? So one has to be a categorical data. The x-axis preferably has to be a categorical data, and y-axis has to be a number, right? So based on each of my category, how my data is being distributed, correct? So you discuss about strip plot, swarm plot, आपको याद होगा, मैं एक बार आपको recap भी करा दूंगा. And then we talked about box plot, violin plot, again showing the distribution, where is how my each of my category wise कैसे distributed data है, कैसे variations हैं इसमें. इसमें आपको box plot में major advantage क्या है? You see the outliers, right? So you see three parallel lines there, right? So top and bottom में को IQR range कहते हैं, data between this is IQR, and then anything apart from that is we call as outliers. So any observation beyond these pointers are basically my outliers, right? And then you have a violin plot. So violin type of a graph, I'll again brief out on that. Then point plot mein you're talking about my change in my the point plot ka objective kya hai? How my data is changing if I move from one category to another category. For example, so I suppose male and female, right? And then we talked about bills, right? So how my spending bill changes, how my bill spending capacity changes from male to female, right? So that is the way, that is the inference we see out from the point plots, right? So that's what we discussed about. Then we talked about count plot. So we again bar plot का extension ही है. So bar plot में आप density को plot करते हो, but count plot में you're actually talking about the exact number of observations per category, right? So we talked about that. Right, so and then facet grids. So we talked about some of the interesting things regarding your regression plot. So we talked about LM plot and reg plot. So reg plot and LM plot again they're giving you the correlations, basically nothing but scatter plot ही है. But scatter plot के ऊपर they are giving you the relation का trend line also, right? How strongly, how weakly the trend is, how weakly and how strongly my x and y are correlated. So instead of directly partially inferring it, we are also plotting a trend line on that, right? they both are same, rec plot and lm plot, they both are same. lm plot में एक ही advantage है आपका, major advantage, you can extend it to facet grid. So basically you have an argument call as call there. So आपको facet grid पता है कैसे करते हो, right? So you can wrap up the columns, you can extend the same graph into multiple graphs for a single column. So for example, I want to analyze how my graph is changing with respect to every day, right? So bill की बात करते हैं. So male, female, so we are talking about the bills, right? So how my pattern changes every day. So maybe Thursday का different pattern होगा, Friday का different pattern होगा, Saturday का different pattern होगा. So I can plot different graphs for Saturday, Sunday, Monday, Tuesday, and like that. And then for that we can have another column, another argument call as call. So if you call this, if you generally use this argument call call, that's basically a facet grid. So you extend your graph into multiple graphs in a single plane, right? So that advantage is that extension is possible in lm plot but not there in rec plot. So that's why it is advantageous. Again, at last we discuss about heat map, right? So heat map is nothing but is more of again a correlation plots only, but here instead of analyzing it by numbers, we are analyzing it through a color palette, right? So each of my number is actually been plotted as form of a color, so a pattern of colors. So that's what your heat map is, right? So again, I'll show you each of these graphs one by one again just to conclude. But again, this is just a overview, guys, right? So always have this kind of a mindset with you, like what do you want to solve. It's not like I come here and tell you multiple graphs का option है, so does not really make sense. But again, it's more like how you can infer things from that, right? How you can understand, what to choose when. This is very important, right? So you cannot just blindly plot any graph for anything. You should have a clear-cut objective of what you want to plot. So always look the data from this front, right? So like univariate है, bivariate में categorical है या numerical है, what exactly I'm trying to plot, right? And then accordingly, जब मैं plot कर दूंगा, what I am expected to see from that graph, what I'm looking at in this graph, what I'm trying to infer, what I'm trying to find out from this, right? So that those kind of things are very important for each graph. Cool. So quickly मैं फटाफट से एक बार सब options पे run through करूँगा. If anybody has any questions, because this is our final class for Seaborn, right? I've already plotted all the graphs for you. I've shown it. This is only one last extension for you because I got a lot of offline comments that they're still confused like when to use which graph, right? So I understand it's a very valid question. Even I was having such queries earlier. I understand that. So that is the reason why I try to tell you like how to think of this as a cheat sheet, right? So how you can just think of and how you can choose the right graph for you, right? So first aesthetics की बात करते हैं, guys. I told you aesthetics में I have three things to take care of. First is my styles. I'm talking about my styles, right? Cool career hunt, I'll talk in correlation in more detail. Allow me maybe 15-20 minutes. So when I'll be talking about heat maps again, right? So in that I'll explain correlations again. ठीक है? So again आपको correlation में simple समझाता हूँ. So abhi like just to start with, so correlation is nothing but basically how my two different variables are correlated. I mean उसका साथ में interaction क्या है? For example, suppose we were talking about this graph, right? We're talking about this thing like if I have on the x-axis, for example, say bills, right, or the total bills, and on the y-axis I have say tips, right? So we were talking about, right, if my bill amount is increasing, for example, then how my tip is changing, right? So we're trying to understand with respect to the change of x how my y is behaving. So that kind of relationships we're trying to understand technically is nothing but correlation. So how these two independent variables from a definition perspective, how two different independent variables are related to each other, right? So that's what a correlation understanding is. So there is a formula behind it. So we might cover the statistical formulas in our statistics sessions in some of the classes. But again, I won't go deep in the formulas. But technically, I'll tell you. So once you calculate based on that formula, right? So correlation can be correlation का mathematical number जो होता है, it lies from -1 to 1. Okay, so that's the range of your correlation का value, right? So -1 being the maximum negatively correlated, right? So that means that my x and y are very strongly negatively correlated. So that means that If my x increases, my y is increasing, my y is decreasing with a very strong steep, right? So it's a very strong correlation, and that means that my if my x is increasing, my y is decreasing. So it's an inverse proportional, inverse relation, right? And then on the other hand, if the value of correlation is +1, that means that if my x is increasing, my y is also increasing. This is a positive trend, right? 0 means neutral. So there is no correlation. There is no effect at all. Nothing is happening. It's all random, right? So it's all random. So again, closer to 1 means strongly positive, and closer to -1 means strongly negatively correlated. So any value which is closer to minus or the plus ones, which are more this shows that the correlations are high or strong. So that's what the correlation is. But again, I'll show you how we can plot that on heat map again. Cool. Coming back, so on the aesthetics front, so we have three things as I told you: styles, context, and my color palettes, right? So styles may basically you're nothing but you're changing your backgrounds, right? So you have option called as set style. So these are the by defaults: dark grid, white grid, dark, white, and text. So by default. The second is plot scale. So scaling में आप क्या करते हो? Set context use करते हो. So I won't go deep here. So context में you have by default these options: paper, notebook, talk, and poster. So nothing but you're changing the scales here. Can you see this? So by default earlier is something like this. So 6, 4, 2, 0, -2, 4, -6. You can see this. The values of y is from -6 to 6. Same way for the x is 0 to 14, right? That's the range here, right? That's how granular this graph is. So it has taken multiple levels, multiple sub levels of my axes, right? But here you can change it. You can change the scale. So instead of having that much of granularity, I'm just simply saying the 0 to 15, for example, with 5 ka window, right? So you have changed you have rescaled it. So it's more zoomed in image. The image is more zoomed in, right? So it all depends where you want to see this, how you want to export this image. So ultimately it has to be used somewhere, right? So likewise we set the context, we change the scale. So that's about my second aesthetic information I have. Third is my color palettes, right? So we use the option called as color palette. We already have seen this. So many colors available, palettes, you can always play around with this. Broadly, there are three categories of my colors. Okay, so again, there are three categories of my colors. So first is random. You can there is no dependency or anything. You can choose this random colors. The second is the sequential data. If my data is increasing, like for example 0, 2, 3, 4, 6, 8, 10, 15, 20, so it's a sequential data. It's an increasing data, right? So that's where you can choose the pattern of my sequence, like greens or blues, so shades of greens, shades of blues. Lighter shades means lower numbers. Darker shades means higher number. Or you can reverse it also. You have option of reversing that. So you have blues and then you have blues underscore R, blues underscore reverse. So you can reverse the color again also. Totally possible. Third is the diverging data. So you have minus or the plus. So any value which is say less than -1, so you can choose a different color like reds, and anything which is plus than more than 1 you can choose as greens, right? So divergent colors. So different palettes you can choose depending on your use. So three things for aesthetics: set style, set context, and palettes, color palettes, right? So do not forget this, guys. All these three are for your aesthetics front. Okay. Now coming back to our data front. So now we are plotting the data on top of my aesthetics, right? So first, as I told you, univariate graph. So univariate में single graph बनता है, single column का graph बनता है. उसमें हम क्या करते हैं? Distribution plot to check the distribution of my individual variable. Correct? Distribution से displot याद रहेगा, कोई confusion नहीं है इसमें, simple है. Displot है. Displot में क्या बनता है? Interestingly आप देखोगे कैसे कॉल करते हो इसको. ठीक है, आप ये इसको भूल जाओ, इसकी ये हमेशा कोई ज़रूरत नहीं है, ये नहीं भी रहेगा तो चलेगा. आप SNS to Seaborn को मैंने पैकेज को लोड किया हुआ है, .displot को कॉल कर रहे हो. displot के अंदर आप यहाँ पे इस फंक्शन को पास, मतलब इस कॉलम को पास कर रहे हो जो आपको प्लॉट करना है. एंड देन PLT, तो मतलब PLT क्या है? मैटप्लॉटलिब है, नथिंग बट. सो मैटप्लॉटलिब आपको पता था, Seaborn इज बिल्ट ऑन टॉप ऑफ मैटप्लॉटलिब, राइट? सो उस ग्राफ को शो करने के लिए बाय डिफॉल्ट आपको शो मतलब मैटप्लॉटलिब डॉट शो करना पड़ता है. सो PLT के तो PLT को मैंने मैटप्लॉटलिब की तरह इंपोर्ट किया हुआ है. सो PLT डॉट शो एट द लास्ट. So this plot is what is the function is like, and then in this you can see the output here, like two things here. So there's my rectangular boxes and the line. Rectangular box is nothing but my bins, individual smaller bins. I told you this, and this is nothing but my trend. You're seeing a reverse U kind of a curve, right? It's a normal curve. Likewise, you can see here if I pass it, just a minute. Uh, my God. Import Seaborn as SMS or whatever it is. SMS. Cool. And now I'm plotting this. I'm putting KDE as true, for example. So now can you see this? PLT is not defined. My bad. Okay. Just a minute. So I'm just gonna run this again. I think I missed this. Yeah. So cool. So now where did it go? Right here. Cool. So I'm going to define this. So now can you see this? This graph has multiple peaks, right? So this is not a normal graph for me, and it could be like in multiple ways. Wherever you're not seeing a graph where it is a single curve and towards the center of my graph, so that is my normal curve, and anything apart from that is not normal. Okay, and you're seeing that this data is not normally distributed. So this is what we are inferring from the univariate analysis, my distribution of my graph. Correct? So bivariate में as I told you two variate का plot है, दो variable है, इधर दोनों न्यूमेरिक होंगे या वन न्यूमेरिक वन कैटेगोरिकल होंगे, दोनों कैटेगोरिकल स्टिल नहीं हो सकते. करेक्ट? उसका कोई मतलब नहीं बनता है. Correct? Because there you have to plot some number on my plot, right? So that is the technical understanding. अब without a number आप क्या plot करोगे? So यही दो ऑप्शन है मेरे पास. So categorical to categorical में भी different चीजें आती है, वो मैं बाद में समझाऊंगा. I won't go that deep in that right now. But अभी मैं इसमें stick करते हैं numeric to numeric में, numeric to categorical में. So numeric to numeric में हमारे पास क्या ऑप्शन है गाइस? पहले ये देख लो. इसमें हमने देखा था इंपॉर्टेंटली जॉइंट प्लॉट, राइट? सो जॉइंट प्लॉट में क्या है, आपको दोनों आते हैं. बाय डिफॉल्ट स्कैटर प्लॉट है यहाँ पे. इसमें आप देखोगे फॉर एग्जांपल कोई भी आप जो इंडिविजुअल इसमें ऑब्जर्वेशंस हैं, इंडिविजुअल पॉइंट्स हैं, दैट इज बेस्ड ऑन द कोऑर्डिनेट्स. यू कैन सी दिस. You can just take a perpendicular line to each of my axes, and that will give you the point of my axis points. For example, if you take this center point, right? If you come down here, so it says petal length coming down at 3. So this observation has a petal length of 3 and a petal width of say somewhere around 1.2. So each of my observation is a 2D representation of my coordinates of my observations. Okay, so that's how scatter plot is, right? And also on top you are seeing the univariate graphs of my individual variable. So that's the beauty of my joint plot. Again, as I told, we can change this scatter plot by default to KDE or hexagon. So this is basically showing you the density. So darker the shades, darker the more the density, right? So you can see that the density here is high, and also here at the beginning is high, and then likewise it's coming lower. So and again another way of representing is using the lines. So KDE. So you can see you are seeing two circles. This is more concentrated, so more concentrated circle, more concentration here. Again a concentration but lesser concentration. So I would say this is more, first circle is more highly concentrated. So where the more number of observations are. So again another way of seeing this. Cool. If you don't want the univariate analysis also to be part of this graph, so you can just blindly omit this. So you can, instead of using joint, you can use a rel plot or a relation plot. So you have an option of by default scatter or line. Okay. So scatter line आप कर सकते हो. यहाँ पर आपको पता है अगर आप rel plot में करोगे and then you have to pass both my x and y by default. So it's a two varied analysis, right? And kind I'm gonna pass scatter or line. So scatter is nothing but again by default x and y representation of my coordinates on 2D plane. And line is nothing but joining of these. So 1, then join 2, then 3, then 4, and 5, 6. So each of the coordinates are joined with a line basically. Cool. So that's how it works. Cool. Right. So I talked about another argument. So there are two arguments which are very important. The first is hue and the second is call. Okay. Always remember, guys. So in any of my bivariate analysis, not only joint plot or not only rel, in all the bivariate analysis, you have this option. Or this is a very common option available for all of your joint plots. Never forget that. Okay. Hue and call. Hue क्या होता है? You are adding one level of granularity in your data. Okay. So here, for example, tip and bill में I'm passing a day, right? So now instead of having all the observation with a single color, this hue will bifurcate my data based on the number of classes. So this mandatorily has to be a categorical information, a category. Okay, this hue cannot be a number. This hue has to be a category. Okay, always remember this. So now I want this to be distributed in terms of my individual days. So Thursday, Friday, Saturday, Sunday. Now I can see the colors has changed for individual observations, right? So now you can more clearly see Thursday, Friday, Saturday, Sunday का क्या the different patterns है. Somehow again it's not very clearly visible here in this particular graph. So you have another option to use call. Okay, so if I just use, for example, say call here, I'll just show it to you. Can you see this? So now your graph is now changed in 4 different graphs. So now you have 4 different observations available. You can see this. I have Thursday, I have Friday, I have Saturday and Sunday. So 4 different graphs of my same variable. So Hugh क्या किया था? Hugh gave you the same graph में multiple option, multiple colors, but call gave you multiple graphs of the same option. Cool, that's the difference. So these two are very important. Hue में क्या था, आपको वो same graph में आया था, but call में it give you 4 different graphs, right? And अगर if you're still not able to understand this minutely, so you can also an option of call wrap. So if you do call wrap, so you can what you can do is you want only 2 graphs in a single row, and then it will be wrapped in a second row. So you can see this now. So now I have more clearer graphs. So I have 2, bigger graphs. So I have 2 graphs and the same row, and then move to the next row for the next 2 graphs. Okay, so that's how things are. So always remember 3 arguments are very commonly used and very important. Hue, call and call wrap. ये कॉल वाला जो ऑप्शन है ना, ये सब जगह अवेलेबल नहीं होता है. जैसे आई टोल्ड यू अबाउट रेग प्लॉट एंड एलएम प्लॉट, राइट? आपको याद होगा, आई वाज टॉकिंग अबाउट दैट, राइट? सो ये रेग प्लॉट में नहीं है, एलएम प्लॉट में. एलएम प्लॉट इज एन एक्सटेंशन. ये कॉल क्या करता है बेसिकली? इट्स अ फेसेट ग्रिड. So it is expanding your grid into multiple graphs, right? So that's the advantage of some of the available graph options we have, right? So hue, call and call wrap, ये important functionalities है, important arguments है, थोड़ा बहुत frequently use होता है. तो मैं भी graph में use किया हूँ बहुत जगह पे, तो guys look at that, okay? So that's about things. So again I'm gonna just repeat that. So hue here is like day. You can see the difference, right? So hue में आपको दिख रहा होगा. So इसमें ये same graph में 4 different colors बनकर के आ गए, but call में क्या करता है, वो different graph बना देता है. So that's the difference. So whatever way you want to see your graph as, and howsoever way you are comfortable to understand it, you can always use the arguments, right? So again that's about rel plot. हमने rel plot भी देख लिया, simple. इसमें बहुत सारी चीजें देखी थी हमने. Again now if you want to plot up again, जैसे आपने यहाँ पे pair यहाँ पे क्या करा था, rel plot and for example here in join plot, you're specifying a particular x and a particular y, right? What if there are say 10 columns, right? So will you be creating 10 cross 10 ka different graphs? So will you be writing 10 times this same code, right? No. So you again have an option to graph all the possible combinations of my graph for available numeric columns by using a graph called as pair plot. Okay. So pair plot क्या करता है, वो n cross n matrix का graph show करता है. If you have 4 say columns, 4 features, so 4 cross 4 का एक matrix बना देगा. 4 cross 4 मतलब 16 graphs बना के देगा आपको. You got it? So that's how it works. Very handy, very handy. And can you see this? So now I have 4 columns here and 4 columns here. So x and y में same 4 columns हैं. And can you see this? So now how you have to read? So across, so this particular x-axis, say sepal length, is plotted against all of its 4 different columns. So sepal length with petal width, with petal length, with sepal width and sepal length. So sepal length and sepal length का क्या हो गया? वो तो same variable हो गया, right? So single variable हो गया. तो single variable क्या होता है? Univariate analysis होता है, right? So univariate analysis में आप इसको distribution check कर रहे हो यहाँ पे. So basically you have an option called as, so जितने भी diagonal plots होंगे इसमें वो univariate graph होगा, and non-diagonal जो graph होगा it's a bivariate graph, right? So आप इसमें देख सकते हो in the diagonal kind में we can have a KDE, a run chart, or in the other ways we can use it scatter or whatever way you want to use. So that's a very handy graph available, pair plot. Yes, carrier hunt. So we can use hue anywhere. So it can be used everywhere, like box plot, join plot, point plot. हर जगह use कर सकते हैं. Everywhere it is available. Cool. So that's my broader first category, numeric to numeric. इसका हमने सारा cover कर लिया. Now the again next broader category is categorical to numeric. So one in this graph, so we need mandatorily need to have one column as a categorical column and the second as the numerical column. So that is something which we have to take care of, right? So in this case, we talked about strip plot, swarm plot, and box plot, violin plot, and all that, right? So let's talk about one by one. सबसे पहले strip and swarm को देखते हैं. ये ऑलमोस्ट सिमिलर टाइप के ग्राफ्स हैं, राइट? सो इसमें आप क्या पास करते हो? अगेन एक्स एंड वाई पास कर रहे हो, बट हियर एक्स हैज टू बी or y in that case, so I mean whatever, preferably x. So x has to be one of the categorical column, right? So here x is a categories, x is non-numeric data, right? So this is what I'm passing here, and then y may I have a number, right? So now we are if we do a strip plot, you're seeing this is how my my individual observations are located under each of my different categories. So setosa, versicolor, and virginica for my species, and my petal length here. And can you see this? For the setosa, my petal length is somewhere between 1 and 2, right? But for the virginica, it is somewhere between 5 to 7. So definitely I'm seeing that the petal lengths are higher for virginica type of leaves, right? So that's how it is. So it's what it is showing here. Also on the swarm plot, it's giving you the exact similar information, but the graphical representation is a bit different. So the only difference here is, so can you see here the number of observation, the individual observation on a 2D plane are getting overlapped, right? So you cannot count the exact number of observation because it is getting overlapped here, right? So you're just seeing a bigger cluster of my information, but you cannot count those number of observations, right? But in swarm plot, you can actually count the number of observation from the graph, okay? Each observation are uniquely represented. अगर किसी पर्टिकुलर नंबर पे पर्टिकुलर वैल्यू पे नंबर ऑफ ऑब्जर्वेशन ज्यादा है, then what it will do, it will just horizontally spread out the information. It will stick to the same area, but horizontally वो बढ़ता चला जाएगा. It will bulge out horizontally, right? So it will not overlap the observation. It will bulge out horizontally. So you can काउंट द नंबर ऑफ ऑब्जर्वेशन. ये स्टिल वैलिड है जब आपका डेटा काउंट छोटा है. अगर डेटा काउंट बहुत ज्यादा हो जाएगा तो आप स्वार्म प्लॉट नहीं प्लॉट कर सकते, बिकॉज वो बहुत बड़ा ग्राफ बन जाएगा. दिस नॉट रियली आई मीन व्हाई वुड यू वांट टू काउंट द ग्राफ नंबर ऑफ ऑब्जर्वेशन, राइट? सो अगेन लुक एट द यूजफुलनेस ऑफ द ग्राफ एंड व्हाट यू वांट टू अचीव, सो देन ओनली प्लॉट. सो बट अगेन टेक्निकली स्ट्रिप एंड स्वार्म में ये डिफरेंस है, ठीक है? देन कम्स द टू अगेन इंपॉर्टेंट ग्राफ्स ऑफ माय डिस्ट्रीब्यूशन ऑफ ऑब्जर्वेशन, अगेन falling under category to numerical type of a graph. So we have box and the violin plots. Very interesting graphs. Box plot and the violin plot, they are again most frequently used graphs, okay? Most frequently used graphs. इसका box plot and violin plot का देखो inference क्या होता है, इसमें से हम क्या हमें देखते हैं. अगर हम box plot और violin plot करें तो basically again we are talking about my distribution of my observation, how my data is distributed, okay, across the categories. So सिंगल ऑब्जर्वेशन का अगर आप डिस्ट्रीब्यूशन देखते हो तो आप डिस्ट्रीब्यूशन प्लॉट डालते हो, डिस्क प्लॉट डालते हो, बट आई वांट टू सी हाउ माय डेटा इज डिस्ट्रीब्यूटेड अक्रॉस मल्टीपल कैटेगरीज, मल्टीपल क्लासेस में, मल्टीपल कैटेगरीज में कैसे डेटा का स्प्रेड है, राइट? अगेन द ऑब्जेक्टिव इज टू सी द डिस्ट्रीब्यूशन ओनली, बट नॉट ऑन अ सिंगल वेरिएबल, अक्रॉस मल्टीपल कैटेगरीज कैसे डिस्ट्रीब्यूशन. दिस इज व्हाट द ऑब्जेक्टिव ऑफ माय ग्राफ्स हियर, राइट? आप इसमें दो चीजें, अब डिस्ट्रीब्यूशन आपको पता चलता है, रेंज क्या है, कितना स्प्रेड है, एंड ऑल दैट. एंड ऑल्सो द सेकंड वेरी इंपॉर्टेंट थिंग व्हिच यू गेट आउट ऑफ दिस ग्राफ इज आउटलायर्स, राइट? आउटलायर मीन्स एनी वैल्यू व्हिच इज नॉट इन द नॉर्मल रेंज ऑफ दैट पर्टिकुलर कैटेगरी. सो एनी वैल्यू व्हिच इज बियॉन्ड द नॉर्मल रेंज. अब नॉर्मल रेंज का डेफिनेशन कुछ भी हो सकता है, राइट? बाय डिफॉल्ट इसमें हम क्या बोलते हैं, IQR होता है, इंटर क्वार्टाइल रेंज होता है बॉक्स प्लॉट के अंदर, which is something between 25th to 75th percentile. अब percentile क्या होता है? I hope people are okay with the percentile का concept, right? Percent and percentile में difference है. Percentile CAT में होता है, percent आपका कॉलेज में होता है, correct? So I hope percentile and percent का आपको knowledge है, but still if anybody has any doubt, do let me know that. So any value which is lesser than 25th percentile or any value which is higher than 75th percentile is called as my outlier, okay? So and the range is the value between my 75th and the 25th percentile is called as an interquartile range, is called as IQR, right, in box plot. So any value beyond this IQR is called as outlier. So that is again a second very interesting inference of my box plot, ठीक है? वायलिन प्लॉट में भी सेम इन्फॉर्मेशन है. वायलिन प्लॉट में अगेन इसमें आपको दो चीज पता चलता है, आपका डिस्ट्रीब्यूशन तो पता चलता है, डिस्ट्रीब्यूशन की डेंसिटी भी पता चलती है इसमें, बिकॉज इसमें बल्जिंग पार्ट होता है, सो वो डेंसिटी भी पता कर सकते हो आप. And the second again is outliers. With the peaks you can identify कहाँ पे outliers किस तरीके से हैं. So you can also infer from that. So दो inferences हैं box plot और violin plot के. अब देखते हैं कैसे plot करते हैं. For example here, can you see this? I'm also passing the x is my category and y is my numerical data. So this is how my data spreads are. You can see this. So parallel lines आपको दिख रहे हैं. This is what my IQR. And any value beyond this, which is you can see here something like this. So you have one observation plotted here for versicolor. So this is my outlier below my 25th percentile data. Cool. So that's how my outliers are. Okay, in box plot. And also you can see this very clearly. So these are my three outliers on Saturday for my bill amount. So bill amount ज़्यादा है. And also you can see this. My data spread is actually increasing evenly on from Thursday to Sunday. So Thursdays में bill ranges कम है, Friday में शायद थोड़े और कम हो गए, and then eventually on Saturdays and Sundays you have I would say थोड़ा सा range बढ़ गया है. यहाँ पे आप देख सकते हो range has increased from on Saturdays and Sunday. Outliers भी ज़्यादा हैं Saturdays and Sundays को, right? राइट. सो डेंसिटी, यस, डेंसिटी आप एक्चुअली वायलिन प्लॉट में देख सकते हो, बॉक्स प्लॉट में डेंसिटी नहीं देख सकते हो. डेंसिटी अगेन वो वायलिन प्लॉट में, दैट्स व्हाट आई सेड. सो वायलिन प्लॉट में यू हैव एन ऑप्शन ऑफ बल्जिंग का ना. सो आई विल टेल यू व्हाट बल्जिंग अगेन इज, बट डेंसिटी कैन बी विजिबल इन वायलिन. सो अगेन every graph has its own plus and pros and cons, right? So box plot में आपको outlier बहुत distinctively दिखता है, but Violin plot में you are inferring the outlier, right? And again at the same time Violin plot में आपको density बहुत clearly दिखता है, but box plot में वो density missing है. So again multiple graphs हैं, उसके inferences different हैं, right? Different हैं. So your objective should be very clear. So what are you expecting from that graph, right? So if you're very sure of what you want from your graph, then there is no issue in that, right? So your objective should be very clear. So that is the reason why I'm still showing you this kind of it's a very quick revision for you. So it's a final conclusion for us, right? So that's how the box plot looks like. But again, coming back, so again, as I said, so hue is by default available for all my bivariate analysis. So by default, right? कॉल सब में नहीं होता है, मोस्टली किसी में नहीं होता है, बट अगेन मोस्टली सब में होता ही है. So hue, but again is available everywhere. So hue is very important thing. So again, what I just did, same graph को मैंने different gender males and females में split कर दिया. Again possible. So Thursday के अंदर I am plotting two different graphs for male and female. Again for Friday, Saturday and Sundays, right? So I'm seeing the trend for individually for males and females for the same bill amount का thing, right? So on top of this, we have another graph which is Violin plot, right? So Violin plot में क्या है, देखो same graph है, day and the bill का मैं देख रहा हूँ. But do you see this? There's something called as a bulging happening here. So bulging मतलब जितना ज़्यादा bulged होगा मतलब उतना ज़्यादा density है उस area में, उतना ज़्यादा number of observations है in that range. For example, here we can see that on Thursday the total bill amount for the bill amount somewhere around 15 is very high. So the bill amount for roughly around 15 amount value of 15 is very high on Thursday. So this is the observation. Again similarly similar trends available on Friday, Saturday and Sunday, but now here you can see this, we have a narrower peak on Saturday. So the peak, the upper peak is more narrower, so that means that there are certain outliers in Saturday, right? On Saturday, again an inference which we can try to infer, but not very distinctive, not very clear if you compare it from box plot. Box plot में आपको you can see these you are able to see these outliers very clearly, very distinctively, right? So here you are somehow inferring it, right? And also you are seeing this part. So this is again a peak, this is again a peak, right? So exactly, it's actually difficult to predict outliers in Violin, but it's quite easy to predict outliers in box. But on the contrary, it's again very easy to understand the density in Violin, but density is missing in box, right? So it's a vice versa, guys. It's a trade-off, right? So every graph has its pros and cons. So you have to figure out what exactly you want to see. So box plot and Violin plot are very, very strongly and very comparatively used most of the times. Again, has their own individual objectives and usefulness. So always mind that, right? Very well said, Career Hunt. Yes. Cool. So इसमें भी हम hue कर सकते हैं. Hue option available है मेरे पास. I have that. Again, I said hue mandatorily has to be a category data. Hue cannot be a numerical column. hue has to be a categorical column. Now in this violin plot, you are seeing this. So this bulging is happening equally on the left and also equally on the right. So basically, if I just take a half of this violin, still give me the same information, right? I can omit this the second half. It's a mirror image. It's a mirror replica of my left on the right side, right? So it's the same image, correct? So that's what our leverage we have in Violin Plot. So if this hue column, the category column has two classes like this, so it has two classes, male and female, I can join these two individual graphs. So again, I have another argument available here, split. If I give split as true, I'm gonna join these two graphs. So because again, the bulging is anyway common, right? So it's the mirror image. So left, right, they both have the other equally spread bulges, okay? So now here, I have joined this. So left bulge will be for male, right bulge will be for female. So this is how, again, a very, very good comparison. So can you see this on Friday? I have more outliers on males, but Friday ko female ki outliers nahi hai, because Friday ko males maybe after office they do party and they tend to pay more, but females are smarter. They are not paying so much bills. They know males will pay for them. So I'm sorry for being gender biased, but I'm just trying to infer it from this, right? And likewise, we have some outliers for females on Saturday, on the contrary, right? So I mean, likewise, so you have to understand, you have to infer things. So again, always very important. This is a very good graph. If you use split is equal to true for two of your, if the hue is of only two classes, it's a very good comparison. You can see the density, you can see the somewhat infer the outliers also, right? So vaguely infer the outliers, but it's a very good comparative analysis if you have if you use a split as true for your two classes of your hue, right? So very good. No, yeah, then you cannot do that. So it has to be mandatorily two classes. If you have more than two classes, then you cannot join. So then the split will not, it will give you an error. But a good question. You cannot join if you have more than two classes. So it has to be mandatorily only two. Okay. So I have written that. So if hue has only two class, then only it is valid. Yes. Cool. So now again we have the statistical estimation type of a graph. We have a bar plot, right? So bar plot again. Here we have my my category here. So for the category, how my density is. So basically, how many number of observations are present for each of my category, and that is the density of my observation, basically, right? So like a total number of observation for that particular category by total number of observation into 100. So basically that's the density, right? So density of my observation for each of my individual categories. So that's how, again, so I have here x as my all of my individual values, and then also I can pass hue. So again, hue is universally available almost all places, all of your bivariate analysis. So I have it here. So this is how my bar plot here. Again, I have multiple sub options here, guys. So please, I have just tried to use some of them. You can just play around with these. So you have a lot of options available. You can change the color, fonts. You can also put some error margins here. So, and then this is basically my confidence interval. And this confidence interval, the standard, I'm choosing the measure of standard deviation. You can change the color from red to yellow, pink, whatever you want. Error width you can change. So you have multiple options. Just play around with this, right? So multiple options you can just play around. So again, also you can orient it as horizontal. So instead of making a vertical stacked bar plot, you can make it as a horizontal play stack graph. Akash, I would request कि आप एक बार playlist check कर लो. So there would be some tutor taking care of CP. I don't really honestly remember the name, but there'll be definitely some of the people. So there are multiple tutors in this channel. So you can just go to the playlist for CodeBeyond, and you'll be able to find what you're looking for. So a specific course if you're looking for. Cool. Coming back. So in the bar plot, you're plotting the density, right? So, but in the count plot, you're plotting the actual count. So that's the difference. Okay. So now here, I want exactly how many individual observations are present for each of my classes. So classes might have first, second, and third class, right? So how many observations are present in each of my classes? So exact number of counts. Okay. So you have the count on the y-axis here. So by default, count plot plots count on the y-axis, and the x you are anyway passing it here, right? and palette also you can give the color. So again, by default, universally present for again all of your graphs. So you can choose palette for any of your graphs. Palette is again by default anywhere available for all of your graphs. Okay. So again from this, you have to somehow infer the number, right? So you can actually plot the data label here. So like exact number on top of the graph instead of somehow inferring it. So you have an option if you're installing the latest version of Matplotlib and SNS more than 3.4, I guess. So you have an option called as bar label. Okay. Otherwise, earlier it was a bit trickier. You have to calculate and then pass it with the height adjustment and the length and the space adjustment on top of that. So it was a bit tricky, but now it's quite easy. So you have just a function available called as bar label. So you can use it by default and it will plot for you. So you can see this. So now I have the numbers also on top of my bars. Cool. So that's my bar labels. So you have the numbers plotted. Again, as I said, so I can pass hue here on top of it. So hue is again universally present. So now I'm passing on the classes whether man, women and child. So like who was the exact person, like a man or a woman or a child, right? So likewise. And again, it will give you 3 individual graphs. I have choose a color palette, magma. Again, you can choose any color, right? So it hardly matters. So I've also given a title here. So PLT the title. So I'm giving a title ka naam survivor. So I'm giving a name to my graph, right? So this is my survivors ka naam, and then I can also add the labels here. So since here it's more of a single, it's not I mean splitting into multiple graphs, right? It's a single bar for me. So I've just given the bar label on a single container. But if there are multiple labels, multiple containers basically, so I have to pass it in a for loop. Like it's anyway by default understood. So for individual containers, I'm gonna pass the value. So again, still possible to put all the labels on top of that, right? So that's about my count plot. Again, interesting, I was talking about the point plot. Remember, so point plot ka, dekho, point plot ka objective kya hai? Point plot ka we're trying to understand the change in my pattern change in my observation from if varying from one category to another category. So what is the change? How my data observation is behaving and how the change is tracked if we move from one category to another category. So that's how that is a say inference of point plot. So here can you see this? It basically plots my the individual data points. So for the male, I have the survival rate of 0.4 in, for example, for the class first, and female is somewhere around say 1. And then it plots it joins these two observations with a straight line. Okay, that shows the trend basically. So it shows that if we move from male to female, the survival rate is changing from 0.4 to 1. So it's increasing, right? So definitely it's an increasing trend. So if it change from male to female, the rate is changing, and that was it's a positive change. So that's how you infer it from the point plot. This graph is again very important, guys. Statistically, it's very important graph to change. If your objective is to find out the change in your the observational values if you move from one category to another category. So again, a point plot is a very interesting plot for you. Cool. So you can see the change in your so from Thursday to Friday it's coming down, but Friday onwards there's a steep curve. So you can see this, the tips are changing drastically from Friday to Sunday. It's increasing. Cool. And this perpendicular lines on this is nothing but my errors. I was talking about the errors, right? The confidence interval, the error. So the range. So although most of the times the Saturday ka tip is somewhere around 3, but it can range from 2.6 to 3.2. That is the confidence interval. So it can range from lower to the higher value, and this is the range. So this is how we see this as. Cool. So that's how my pair plot was. Now on this same category, the point plot ka extension hai factor plot. Okay, so point plot mein we have technically point plot mein we don't have call. Okay, so we cannot facet grid this. So point plot ka extension hai factor plot basically. Okay, so factor plot mein without any information, suppose if I'm just using the same thing like x and all that, so I'm gonna get the same graph which I'm getting in my point plot. Isme ek aesthetic difference hai, wo hai it is giving you the graph in form of x and a y column. Okay, but here it's more of a box plot. So you can see in this, So you have a top and the right spines also, right? You can anyway de-spine it, that's always possible, but by default it's giving you a rectangular box kind of a graph, right? But here aesthetically it is giving you x and a y. So that's again an aesthetic advantage of using factor plot. But again, factor plot is almost equivalent to point plot, okay, if given the standard values. But again, extension मैंने बताया, इसमें हमारे पास दो तरीके का extension है. We can actually change the kind of trend we want to see. We have an option called of kind here. So kind में we can pass both box and the violin. So instead of using it as a points, like an individual point, I can plot it in form of a violin plot. So violin plot में I'm changing the changes here. So again, so basically violin plots individual hue के आपके violins बन गए यहाँ पे, right? So that's the kind I'm using as a violin. I can also pass kind as box, right? So again an advantage on factor plot. So instead of seeing it as individual points, I can either see it as a violin or a box. So again possible, you can see this. But the major advantage here is we have an option of call. And call आपको पता है क्या करता है? Call facet grid करता है. So it splits, it makes individual graph for individual category का नाम here. So diet में अगर multiple options है, so I have no fat and the low fat diet. So it will create two different graphs for this. So this extension is not available in point plot. Okay. So point plot, factor plot has two advantages over point plot. The first is aesthetically तो आपको पता ही है, वो तो by default है, वो x and y में दिखाता है. The first advantage is it has multiple options. Instead of using only point, it gives you two more options. I can use either violin or box for my relational analysis. The second is it has an option of facet grid. It can extend your same data into multiple graphs if you want to. I mean, if you want to, basically, right? So it has an option of call. ये call आपको point plot में available नहीं है. So ये extension है आपका factor plot from point plots. Again, a very pinpointed thing. Cool. That's it. So now the last two categories. The last two में क्या है? एक तो linear relationships. Okay. So now scatter plot आपको मैंने बताया था, right? So scatter plot में somehow we were trying to infer कि how my if my x is changing, how my y is changing, right? So that kind of inference I want to have from a graph, right? So उसी के लिए basically ये relationship plots हैं. So वो क्या करता है, पहले by default it plots a scatter plot for you, right? And then on that scatter plot it plots the trend line. So how this trend line is, so what is the I would say correlation in that sense, how my values are actually changing. So is it a positive trend, is it a negative trend? So how my trend is changing with respect to change of my values, right? So that's where you have two different plots for linear relationships. I have reg plot, regular plot, or my LM plot. Okay, so इसमें आपको मैंने बताया reg plot and LM plot, they both are equally they both are similar. Okay, the only advantage which LM plot has, it has facet grid. So the जो call वाला argument आपको मैं बता रहा था, that call वाला argument is available in LM plot, but वो reg plot में नहीं है. So LM plot में technically सिर्फ यही advantage है. ठीक है. Again aesthetic तो आपको पता ही है, जो aesthetic में क्या है, basically वो x and y में दिखाता है LM plot, और reg plot आपको box में दिखाता है. So ये aesthetic change है. ठीक है. Again आप देख सकते हो यहाँ पे. So again I'm plotting my total bill over tips. So total bill is my x and tip is my y. So this is basically nothing but my scatter plot, and the scatter plot में I'm plotting this trend line. So interestingly, in this trend line also you're observing there's a shaded area, right? So shaded area below and top of my trend line. So this is nothing but my confidence interval, guys. Again, so confidence interval, my errors, right? So potentially the values of my the trends can change from this to this. So this is the range of my errors, right? So narrower the confidence interval, more confident I am, more good my prediction is, right? Better my prediction is. More good question, better my prediction is, right? So likewise again, अगर ये ज़्यादा होगा, अगर confidence the shaded region वो ज़्यादा होगा, मतलब I'm less confident, मतलब errors ज़्यादा हैं, I'm less confident, my values are I would say it's not a good I would say trend basically. Cool. So that's the inference. LM plot, reg plot दोनों almost similar है. Again इसमें मैं वो shades off कर सकता हूँ. So I have an option of like CA is nothing but my confidence interval. अगर मैं इसको none कर दूंगा तो I won't get this shaded वाला part, right? But again it's what it's how what you want to see and how you want to show basically. So that's what you want, right? LM plot आपको मैंने बताया था सेम ग्राफ है. LM plot और rect plot आप देख सकते हो, is again the same, almost same graph. Aesthetically it has top in the right axis, but LM plot में it does not have the top in the right axis, so that is aesthetic change. But again the major technical change is it has an option of hue. Sorry, it has an option of facet grid, so call. So call argument आप adds कर सकते हो to make it as a facet grid. So now instead of having a single graph, it is now plotting you multiple graphs day wise. Day wise के क्या trends हैं. And each of these individual graph में भी आपको trend आएगा. क्या trend line है? Increasing है, decreasing है. So वो trend line again will be visible. Cool. So that's the technical advantage of using LM plot over rect plot. But again, these both are my linear relationship का plot. ठीक है? The last category is my heat map. Heat map क्या है? It's a two-dimensional graphical representation of data in form of your colors. Correct? So इसमें भी again मैं it's a bivariate analysis only. मेरा x and y में two-dimensional data ही है. But instead of numbers, I am now representing these numbers with the color ka shade. Right? So that's what my heat map is. Instead of plotting its form of a number like a scatter plot and something else, I'm just plotting these numbers as shades of different colors, right? So that's how I'm going to visualize this as. So this is what my data looks like. So I have, say, month-wise, year-wise, how many passengers are there, right? For example. So I have just called heat map on this entire data and I've given some color coding. So red, blue ka color coding मैंने दिया है. So can you see this? This is what? Now this number, which is starting from 112, I have changed it to colors. So technically, I'm not seeing any number here, right? I'm just inferring it how my data is changing, how my relevant changes are, how my how the color patterns are changing from one square blocks to another square blocks, right? So so here I can see the darker shades, and then it is getting lighter, then it's coming a lighter shade of blue. So here blues are my higher number, so 600 is the highest, 200, and then below than that is the lowest. So the darker reds are my lesser number, so it's like a red zone for me, right? Blue is like safer zone, more number of passengers, more safer. So likewise, if you have a data where you want to have like reds are good, blues are bad, so you can use red blue underscore r. So in this case, you're gonna reverse the pattern. So you have to understand, right? So what is your data and how you want to see the data as, and accordingly you have an option of colors also. Accordingly you can choose your colors, right? So what do you want to plot as, how you want to infer this as, right? So that's how. So just these numbers are now shades of colors. So that's what my heat map is, right? But again, technically you are seeing this, right? So this is not very distinctive, not very clear. And each of the color blocks, like this first block, second blocks, are joined, right? So मुझे वो shade का difference नहीं पता चल रहा है. So what I generally do, I always use this argument, which is nothing but like line width, and I always use 0.5. So line width, if I use 0.5, this graph becomes more friendly. Can you see this? Now this individual graphs, individual square blocks is very distinctive. It's separated by a width of 0.5 each of my blocks, right? So now I can distinctively see individual blocks, right? अब इसमें color patterns क्या हैं? Now I can see this. Cool. Here I have used the CMap as twilight, so I have used a color pattern. I use a different color pattern. You can use anything, yeah. Greens, blues, जो भी अब इसको सब blues भी कर सकते हो. Green से कर लेता हूँ. I can use greens. So it's greens CNI and greens capital है क्या जी? Okay, so you can use that greens. So again आपको दिख रहा होगा lighter shades less है. Again it's a sequential data, तो greens भी use कर सकते हो. So 600 darker shades of greens ज़्यादा अच्छा दिख रहा है. So more number of passengers. You can see this area 1960 towards July and August, most number of passengers are there, right? So again increasing. This area is whole light, right? So depending on what kind of graph you want and how you want to infer that. Correct. So line width, it gives the graph more friendly appearance, right? So again it's more of a number ka representation on my colors, right? So that's what the correlation also give you. So correlation आपको मैंने बताया था. Again somebody asked this question. So correlation is nothing but my relationship का statistical number between my two variables. So two of my individual variables का statistical correlation क्या है? How strongly they are correlated. मतलब इंटरेक्शन कैसे है. सो आई वोंट गो इनटू द कैलकुलेशन पार्ट, बट दिस कोरिलेशन का वैल्यू जो होता है वो -1 to +1 में रेंज करता है. -1 मीन्स मैक्सिमम स्ट्रॉन्ग नेगेटिव कोरिलेशन, +1 का मतलब स्ट्रॉन्ग पॉजिटिव कोरिलेशन, 0 का मतलब नो कोरिलेशन. ओके, जितना ज्यादा वंस की तरफ होगा उतना स्ट्रॉन्ग रिलेशन कहलाएगा. ठीक है. So I have just called this function cor CORR. It's inbuilt function of Python. जब इसको कॉल करते हो ना तो आपको वो हर एक न्यूमेरिकल वेरिएबल के अंदर का वो कोरिलेशन दिखा देता है. सो वो कोरिलेशन जनरली हीट मैप हम कोरिलेशंस को प्लॉट करते हैं. ठीक है, ये कोरिलेशन आ गया. एंड देन दिस कोरिलेटेड डेटा जो है जो आपने कॉर में सेव किया हुआ है, आई एम नाउ प्लॉटिंग दिस कोरिलेशन का डेटा ऑन अ हीट मैप. ठीक है. सो नाउ इन दिस हीट मैप में मैंने कोरिलेशन को प्लॉट कर दिया, सी मैप दे दिया, लाइन विड्थ दे दिया. अगेन यू आर सीइंग दिस एंड नॉट. सो एंड नॉट बेसिकली क्या होता है, एनोटेशंस होता है. सो एनोटेशन मतलब बेसिकली, सो ईच ऑफ दीज इंडिविजुअल स्क्वायर्स, ऑल्दो कलर तो है बट आई ऑल्सो वांट टू सी द एग्जैक्ट नंबर ऑफ. सो नंबर क्या है, सो इसके ऊपर आप नंबर का लेबल भी डाल सकते हो कि एग्जैक्ट उसका वैल्यू क्या है. सो दैट इज थ्रू एनोटेशन. सो यू कैन जस्ट पार्स दिस आर्गुमेंट एनोट इज ट्रू, सो यू गेट द labels also for each of your color square blocks. So that's about the heat map, guys. So I think I'm pretty much done with this. So I've concluded. So is my main point which I want to highlight here is you have to be very sure of what you want to achieve by plotting the graph. What is your expectation? What is your what are you looking for? What is the output you want to have from the graph? So that is something which should be very much clear to your mind, what you want to achieve, right? And the second is, accordingly, once you have plotted the graph, how you going to read it? So what is the inference? Okay, so it's not about plotting a graph, it's also about reading the graph, right? So I would highly recommend that you should be having a proper clarity of reading the graph, right? Guys, I'm going to give you quick maybe a couple of minutes. If anybody has any questions from anywhere, do let me know. I'm going to wrap up Seaborn now. So from next class onwards, for the same playlist for data science with Python, we're going to start something else, but Seaborn would be done. Cool. So that's all about visualization, guys. So visualization is very important. It's the key aspect of your data exploratory analysis. ग्राफ्स आपको पता है नाउ, हर टाइप के ग्राफ्स पता है, बट कब कहाँ यूज करना है ये पता होना बहुत जरूरी है. आई थिंक दिस इज व्हाट दिस क्लास वाज सपोज्ड टू मीन. Cool. Anybody has any questions, guys? All good? I hope you guys are able to understand what we're trying to do here. Cool. So if we are good, then thank you so much. I highly appreciate the patience, and thank you so much for being with us for the channel today. Cool. Great. So it was really nice talking to you. Thank you so much, Career Hunt. So I hope I was able to clear your doubts. Again, any questions, guys? Anything which you feel like you want me to cover, or which you feel that you have a confusion on? Multiple arguments are there, so do definitely try them. And you will find something new again. Cool. So with this we are done. So let's meet again tomorrow. So but again tomorrow I'm switching back to Python, so which is advanced Python scripting. So I'm gonna covering NumPy there. So we have a refresher session on NumPy tomorrow. So at 9 p.m. So we were doing NumPy some time back. So I'm just gonna quickly recap a few of the things of NumPy functions. And the respective next 2 days would be finishing up my important functionalities available under NumPy, right? So NumPy is again one of the very good packages for data scientists. Cool. So we'll take care of NumPy for the next 3 days, right? So for tomorrow and then the respective next 2 days. So and then we're gonna meet at 9 p.m. guys, same time. Cool. Thank you so much with this. I'm gonna give you an evening back. Tableau is again there, so one of the softwares, so it's not a mandatory one for you. So Tableau, I mean, it might be like some company would be using Tableau, some would be using Power BI, some would be using something ClickView. So they are like, Tableau is another software for visualization, and likewise Tableau के अलावा बहुत सारे like there are 10 more softwares, right? So I mean, you cannot just keep on learning softwares, right? So my recommendation is, if you are looking for data science, your mandatory skill sets are stats, ML, Python, SQL. Focus on them. Do not. I won't say that Tableau is bad. Tableau is definitely very good, but it's a software, right? It's a tool. So do not run behind tool. Run behind the technologies. What if Tableau is out of market, right? You lose your job, right? So don't run behind tools. Run behind the technologies or the concepts. So stats, ML, Python, SQL is your mandatory skill sets. Tableau or any other tool is depending on the job requirements. So if the particular job is looking for you to be good in Tableau, then yes, maybe yes, you have to learn that. But again, if you can skip that job, if you can, if you're okay to lose out on that job, that's pretty much okay. But again, it's not a mandatory skill set. Cool. Thank you so much, guys. With this, I'm gonna give your evening back. It was really a pleasure talking to you. So let's meet each other tomorrow, same time, 9 p.m. with NumPy. Thank you so much. Bye bye.